Multiple choice chemistry 2024. Question 1. Which two substances are members of the same homologous series? The answer is A. Homologous refers to structures of the same identity that differs in carbon chain length. So only A is of the same functional group. Both are alcohols. 2. Aboriginal and Torres Strait Islander peoples have used leaching in flowing water over several days to prepare various foods from plants that can be toxic to humans. What was the reason for this? The answer is B. To dissolve low solubility toxins. This is to do with KSP or cyclosin, where the KSP is less than 1. Leaching in flowing water over several days reduces the concentration of the toxin, which effectively favors the equilibrium to the right-hand side. 3. Which of the following compounds can be correctly described as an arrhenius base when dissolved in water? The answer is D. Sodium hydroxide. An arrhenius base is a substance when dissolved in water gives a hydroxide. 4. An infrared spectrum of an organic compound is shown. Which of the following compounds will produce the spectrum above? So it's pretty easy. If we're looking for a ketone, which is featured in B and C, while the ketone stretching between 1680 and 1750 is not present in the current IR spectrum, because the actual spectrum shows signals around 3500 to 3000, whereas D is only in the fingerprint region. So the most probable answer is A. 5. Which would be the best reagent to use to determine whether an unknown substance was 2-methylpropyl-1O or 2-methylpropyl-2O? The answer is D. Acidified potassium permanganate solution is dark purple, and after the reaction has taken place, it reduces to manganese 2+, which is a brown color in acidic medium. Now what this is doing is that the best way to decipher the two types of alcohol is that primary alcohols oxidizes to an aldehyde, whereas a tertiary alcohol, when treated with acidified permanganate, does not react. So just the extension to question 5. The reason for acidified permanganate is because it becomes a stronger oxidant compared to the alkaline version. 6. What is the hydroxide ion concentration of a solution potassium hydroxide with a pH of 11? So we know the relationship pH with pOH equals 14. If pH equals 11, that means pOH is 14 minus 11, which is 3. To work out the concentration from the pOH, that is simply equals to 10 minus pOH, which is 1 times 10 to negative 3 moles per liter. So the answer is B. Question 7. The following equilibrium was established in a container. Which of the following would decrease the yield of SO3? So this particular equation is exothermic. The only answer is C. 8. Which pair of ions produce different colors in a Flynn test? The only answer is C. 9. Which of the following is the mass spectrum of ethylamine? The structure is given below. It's CH3, CH3, NH2. So if we were to do a breakdown of the possible fragments, then the only closest one is B. 10. The following system is an equilibrium. A catalyst is added to the system. Which row of the table correctly identifies the change in the yield of propyl and the reaction rates? So adding catalyst increases the rate of reaction by lowering the activation energy. That means the both forward and reverse reaction increases. The yield of the product remains the same. So the answer is B. 11. Which is the correct expression for calculating the solubility in moles per liter of lead iodide in a 0.1 moles per liter solution of sodium iodide at 25 Celsius? This is a common ion effect calculation. You have lead iodide makes lead 2+ and 2I-. So you'll need to go to the chemical data sheet to get the KSP value for lead iodide. Since it goes into sodium iodide, the iodide portion is the common ion effect. Iodide is 0.1 moles per liter. We don't know the identity of X, so using the ICE method, we can say that the expression becomes lead2 plus equals KSP divided by I minus square. I minus is formally 0.1 plus 2x, but that is being approximated down to 0.1. We are able to do this because KSP is small. So then the final expression becomes 9.8 times 10 to the negative 9 divided by 0.1 squared. The answer is D. 12. The structure of an organic substance. What is the preferred IUPAC name for this substance? So very quickly, you should know that it's an N-ethyl something, not a 1-ethyl. The nomenclature goes that you use N and then the next adjacent atom is the carbon number 1, 2, 3, and 4. What is attached to N is CH3CH2, which is an ethyl. So then using that nomenclature, the only answer is 3-chloro-N-ethylbutanamide, which the answer is C. 13. The fuel has these enthalpies of combustion: negative 2057.8 kilojoules per mole and negative 48.9 kilojoules per gram. Which of the following correctly identifies the fuel? So this is just a mathematics question. If you take kilojoules per gram times it by grams per mole, you get kilojoules per mole. So the trick is to multiply 48.9 with any of the molecular mass to see if it works out to be 2058.69. Otherwise, the alternative way is simply take kilojoules per mole divided by kilojoules per gram, which works out to be grams per mole. And so if you to divide 2057.8 divided by 48.9, 42.08 rounded up to 42.1. Answer is C. 14. Glycine, an amino acid, can react with itself or other amino acid monomers to form silk, a natural polymer. Glycine has a structure. A section of silk polymer is shown. Which monomer could react with glycine to form this section of silk polymer? Again, this is just to match each of the monomer option to the silk polymer and decipher what is the closest one. So B is the only segment that makes sense. 15. The thermal decomposition of lithium peroxide is given by the equation shown. Mixtures of lithium peroxide, lithium oxide, and oxygen were allowed to reach equilibrium in two identical closed containers, P and Q, at the same temperature. The amount of lithium peroxide in container P is double that in container Q. The amount of lithium oxide is the same in each container. What is the ratio of oxygen gas in container P to oxygen gas in container Q? The only answer is A, because this is a trick question. You don't need to know anything other than oxygen. Solids are not counted in a heterogeneous mixture of an equilibrium system, so whatever the changes are done between P and Q don't matter because they're solids. Only the oxygen matters because it is gas. And in both systems, the oxygen is the same, so it's a 1:1 ratio. 16. Which of the following is the overall reaction that takes place when a strong acid is added to a buffer containing equal amounts of acetic acid and acetate ions? The only answer is C, because the first one, A, is formic acid, B is a base, and D goes from acetic acid to a diol. If you were to write out the equation, you have weak acid plus H2O goes to CH3CO minus the conjugate base and the acid. The base consumes the strong acid without affecting the buffer's pH, which is how a buffer should work. You have an equal amount of the HA to A minus, so then the buffer counters the strong acid. 17. 20 ml of a 0.1 molar solution of an acid is titrated against a 0.1 molar solution of sodium hydroxide. A graph of pH against the volume of sodium hydroxide for this experiment is shown. This is a buffer question. The answer is C. Why is that? You have to use the Henderson-Hasselbalch equation, which is pH equals pKa plus log 10 concentration A minus divided by concentration HA. When you have a titration curve, all you need to do is to find the equivalence point. There are two equivalence points, so that means we're dealing with a diacritic acid. Now, half of that is where the condition goes that you have an equal amount of the A minus to the HA. When that is the case, you have a 1:1 ratio of A minus to HA. So then log 10 of 1 equals 0. The pH equals to pKa. And so we just simply read off from the graph. The first pKa number 1 happens at 10 mils, which is 1.91. 20 mils from 10 mils is 30 mils pKa2, so then that is at 6.30. So the answer is C. For further explanation, please pause the video to read the entire explanation provided by Cognito Tuition. 18. A reaction mixture not at equilibrium is composed of both N2O4 gas and NO2 gas in a closed container. The reaction quotient for the system, Q, is given. So the rate of the forward reaction is initially greater than the rate of reverse reaction, which diagram shows how Q changes over time for this mixture. Q is less than K, which will eventually reach equilibrium. The forward reaction is favored since NO2 is on the right-hand side of the equation. It will need to come from the decrease of N2O4. So NO2 will be increasing in concentration. Between A and B, the answer is B because the concentration of NO2 does not start with 0. 19. Which of the following compounds produces two doublets in the proton NMR spectrum? The answer is A. In the following slides, please pause the video to go through the entirety of the analysis. Some may differ from other answers found on the internet, but nonetheless, the answer is A. This is the analysis of structure A. This is the analysis for structure B. This is the analysis for structure C. This is the analysis for structure D. Question 20. The concentration of ascorbic acid in solution A was determined by titration. A 25 ml sample of solution A was titrated with potassium hydroxide solution. 50 mg of ascorbic acid was added to a second 25 ml sample of solution A, which was titrated in the same way. Titration volumes for both titrations are given. What is the concentration of ascorbic acid in solution A? So the answer is D. When you approach a back titration question, you gotta have a template, and this is the template. So the idea of a back titration is you have something, a substance, in this case ascorbic acid, that cannot be titrated directly against the potassium hydroxide. So ascorbic acid will need to be embedded into something else, and that something else is then compatible to be titrated against the base, which is in this case potassium hydroxide. And so in order to know the identity or whatever the question asks you to figure out for ascorbic acid, you need to go all the way to the end of the process, which is know the identity of potassium hydroxide by knowing its mole. Now you can get the mole usually from the concentration equation, which is C equals N over V. In this case, both the concentration and the volume are not given in the question. the first step is you need to figure that out. And that is what we're going to attempt to do. Now, once you understand the identity of potassium hydroxide, then we can proceed to figure out the amounts of excess, which is the titrant. And then that leads to the amount of solution A reacted with ascorbic acid. We are going from the back to the front. Now, interestingly, for this question at least, the solution A total reagent used isn't provided, but that is not a problem because we can still work around it. The first step is to understand our system. Because the system itself doesn't have any indication of what solution A is, we do know the identity of ascorbic acid and potassium hydroxide, so that's easy. But without knowing the identity of solution A, we cannot write a balanced chemical equation. And in order to answer this question, we can assume everything that's connected to be a 1:1 ratio. Step 2. Determine the volume of potassium hydroxide needed to react with ascorbic acid. We have 25 ml solution A plus 50 milligram of ascorbic acid requires 33.10 ml of potassium hydroxide. Then the first one is 25 ml solution A requires 17.50 ml of potassium hydroxide to reach equivalence point. If we were to subtract 17.5 from 33.10, then we can figure out how much potassium hydroxide was needed, the titrant, to titrate against ascorbic acid, because when you take the two, you are essentially subtracting solution A from the equation. So the answer is 15.60 ml. Step 3. Determine the identity of solution A, the amount of solution A reacting with ascorbic acid. So we're going to use the available data of 50 milligram ascorbic acid. The mole is 2.83 times 10 to the negative 4. The mole of potassium hydroxide is the same as ascorbic acid. Determine the concentration of potassium hydroxide of 15.60 ml that is related to the 50 milligram ascorbic acid. Previously, we worked out that the volume of potassium hydroxide related to the ascorbic acid is 15.6 ml. We also determined that the mole of potassium hydroxide is the same as the mole of the ascorbic acid. From these two values, we can determine the concentration of potassium hydroxide, which works out to be 0.018198 moles per liter. 3. Determine the mole of solution A excess from potassium hydroxide and the volume of potassium hydroxide. We know from the table the volume that is directly associated with solution A is 17.50 ml. So we're going to be using this volume and the concentration that was determined in the previous step. We can work out the mole of solution A in excess, which works out to be 3.184 times 10 to the negative 4. Determine the mole of AA in solution A from N equals solution A excess. So again, we say that the relationship of the ascorbic acid in solution A is equal to the solution A excess due to the fact it is a 1:1 ratio, and that is the mole determined previously. Step 4, determine the concentration of ascorbic acid in solution A in 25 ml of solution A. We're going to be applying C equals N over V. The mole is 3.18 times 10 to the negative 4 divided by 0.025 liter. So the final answer is 1.274 times 10 to the negative 2 moles per liter. Thank you for watching. Please follow and subscribe to this channel for more quality content. I'll see you next time.